All right, CNT140, we're looking at Chapter 10 on terminations. The nice part is this will be a big old review of a bunch of terminations we've already done, and a couple new tidbits of things we haven't done. First thing they talk about here is actually coax termination. So this is worthwhile to at least kind of understand what you're doing for terminating coax. The majority of coax terminations we'd be doing is with your RG6, I think I put it out here, your RG6 cable right here for basically your cable TV or your cable internet coax connections. That's what the majority of them would be. So for that, we're using most likely an F-type connector. That's the type of connector we're using. And I remind you here, this is your F-type connector right here. This is your B and C connector here. So more likely we're using an F-type connector on RG6 coax cabling. So the tools we need to do this are, cutters, your wire stripper, and then I need some kind of crimping tool. And there is a, if you're dealing with coax, there is a Crimp style connector, and there's also a compression style connector. So as we're doing this, I'll show you both. So to do this, the basic gist is I will need to strip the jacket off so that I expose the shielding inside, and then eventually the copper conductor in the center. Pull the shielding back over the jacket, make sure that the shielding is back over, slide the connector on, and crimp the connector on. So, and the book gives you roughly this picture here, this picture process. But let's examine a little bit more. There's my RG6, and just to know the difference, here's a crimp style F-type connector, and here's a compression style F-type connector. This would be kind of the connector that most people have seen, but if you look more closely at the ones that maybe like your Comcast or Verizon puts in, it's usually the compression style here. This is a little bit better quality termination for coax. First thing I'll do is I'll take my coax stripper and make sure it's adjusted that the jaws are cutting correctly. Two things need to happen. You need to cut the outside jacket just down to the level of the shielding, but not through the shielding. And then the other blade in there needs to cut through all of that and down to the center conductor. So there's two blades in there that need to be adjusted. And this would be worthwhile to take, a scrap of coax and adjust the blade so that it's doing that correctly. Feed the coax into your stripper, give it a turn or two around, and make sure that again the first blade out here is cutting through the jacket and not the shielding, and then the second blade here is cutting down through jacket, shielding, the insulator in here, so you're down to the copper conductor. So those two things need to be occurring when you adjust that. Once I've done that, I'll lay my braided shielding back over the jacket. I'll fit my connector over, whether it be compression or crimp style. I'll fit that over the coax cable. And here's showing you correctly what the compression fitting looks like when it's fitted over, and your crimp style connector, what it looks like when it's fitted over. And then I will put these into my crimping tools, either my compression tool or my crimping tool, and crimp the connector onto the end. And then there is a completed connection of either the compression style or the crimp style connector. Okay, so worthwhile at least to know the process in case you have to run into doing that. The rest of our chapter is pretty much going to be spent on our terminations for our twisted pair cabling. And they remind us that 5E and 6 is commercial installations, Category 3 and 5E for phone, but the majority of the things we're going to be dealing with is our 5E or 6. They remind us here in the introduction of a couple things, so I pulled up a couple things from your for your memory, if you will. According to our standard, every location should have two drops, and idea is one is being used for data, one being used for phone, and I'm going to use a modular 8-pin jack for both of those. And my two drops, I'm also reminding you, here's our cable structure. Okay, the closet end is going to be terminated to our patch panel. The work area end is going to be terminated to our outlet. All my components need to be similar rated, as we talked about in last chapter. That keeps all the impedance the same. Our whole system should be 100 ohms impedance. Matching all the categories through keeps our whole system at 100 ohms impedance to keep our structural return loss value down, so that we can have a good quality link. So my whole system here, my whole horizontal cabling system, patch panel should be Category 6, my cabling, Category 6, outlet jacks, Category 6, patch cables, Category 6. The whole system needs to be rated the same category to keep it at the same ohms impedance on the whole system and have maximum power transfer, if you will. That's what we're getting at. They also remind us when we're pulling cable, watch the pulling tension. I pull more than 25 pounds, I'm going to start untwisting the wires inside the cabling, and that's going to affect the signal quality of my data moving across there. And here's the whole, 25 pounds of force pulling tension is the maximum pulling tension. That's why our boxes are designed to be laid this way, and I pull the cable out, I'm kind of gently feeding them out, or I'm putting them on some kind of spool, or putting all of them on a giant spool so I can pull them at the same time so I don't have kinks and bends. If I have to route my cabling through any kind of ductwork, any sort of conduit, make sure I'm doing it through gently. If need be, use pulling lubricant to do that. That reduces the friction of the cabling moving through that conduit. As I'm routing my cabling, watch the bend radius. 4 times the cable diameter is the maximum bend radius that you have. And it's roughly, I kind of give you a ballpark about the size of a quarter that I'm trying to bend out. That's the tightest bend that I should have on my twisted pair cabling. I also remind you about solid and stranded cabling. Okay, the solid cabling is my horizontal cabling right here. That gets terminated into my patch panel and my outlet jack. My stranded cabling is my patch cables right here. This is my stranded cabling. That gets terminated with my RJ45s. Okay, so my stranded cabling is getting terminated with my RJ45s, so it's things like patch cables. My solid cabling is getting terminated into my patch panel and my outlet jacks. Okay, and here's my outlet jack here. There's my patch panel there. My untwist on all my terminations, again, 1/2 inch max untwist. I untwist more than that, and I'm allowing my signals to jump from wire to wire. I'm allowing for crosstalk to happen. So I got to make sure all my terminations are good quality terminations. As I'm looking here, there's a lot of untwist on all of these. I'm looking for more like this, a bunch of twists up to the termination point, a bunch of the twists up to the termination point. That's what I'm looking for. We also need to remember our color codes. Don't forget our jack color codes, 568A on the jack, 568B on my jack, and my color codes on my patch panels. Okay, remember these were a little tricky to read. Here's A listed across the bottom here, here's B listed across the top. Watch carefully as you're terminating. And also watch your color codes for your RJ45 terminations. 568A color code, 568B color code. Our categories of cabling. Remember, as we've talked multiple times now, as we've started to increase frequency through our cabling, the structure of cabling has had to change to be able to keep the system at 100 ohms impedance. So category 3 barely twisted, category 5 twisted much greater to keep it at 100 ohms with a higher frequency. Category 6 higher frequency through, we had the separator in the middle to keep it at 100 ohms. Category 6A higher frequency, we've now added shielding here to help protect those cables and get the higher frequency through. Category 7, we're starting to see each wire pair is shielded and the outside of the cable itself is shielded. The structure keeps changing to keep it at 100 ohms after we have increased the frequency of the signal moving through. Alright, so the first terminations they talk about with twisted pair now, and actually that was all just to kind of remind you of all the things we do know to this point, make sure all that's in your head. Now as we move into the first terminations, one of the first terminations they talk about is terminating into a 110 block. Well, 110 blocks I might encounter when I'm dealing with phone and early data systems. So it's worthwhile to at least mention what's going to happen. So to do this, there is my 110 block. I have the wires coming into the block itself. Then I have the connecting clip or the connecting block on top. Okay. First thing is I'll mount my 110 block to the wall. I'll feed my cables through. Once they're fed through, I'll then strip some insulation off those cables using my little wire stripper that we're used to using. Pull the insulation off. Once that's done, I will untwist my pairs and lay them into the block. Here in my color code order. Once they're that way, I will use my punch down tool and I will punch those wires into the block. Okay, and remember our 110, our punch down tool here, 110 blade. I'm looking at the chisel side here. Here's the chisel side right there. Okay, that'll be the side that I'm using to cut the excess wire off. There, all the wires are terminated into the block. Once they're terminated, I'll take my little connecting block, my 110 connecting block. Well, if you look at it closely, this looks like a patch panel right here. On the other side is the little metal V's. So as I snap this block, and what's going to happen is the block's going to get snapped on the top of the 110 block here. As that little connecting block gets snapped on top, these metal V's are going to excuse me, those metal V's are going to go down over the wire, and the metal V is going to slide down over top of the wire, cut the insulation, make contact with the wire inside. It's an insulation displacement connector. Okay, so that little 110 connecting block is going to get put into my tool here, and that is going to get punched on top of the 110 connecting block, like so. And what it does, it terminates those wires that are in here already. The connecting block is going to go on top, and it's going to terminate those wires. Now I have it terminated, I can label my block, and now I can plug into it or terminate on top to it for use. Okay, I might run into that for phone terminations and early data. The nice part is we're going to see a lot of that process and a lot of that similarity when we look at our patch panels or think back to our patch panels. So the next obvious thing here, they didn't talk about it, but I put it in here, terminating a patch panel. This is going to look very similar. You know, trim my wire to length, strip the insulation off, prepare the wire pairs, separate the pairs, untwist them, lay them into my patch panel. Hey, that looks like the 110 block. Exactly. That's where that came from. This piece right here, this piece back part of the patch panel came from the 110 block system, which 110 block was developed by AT&T, by the way. Hey, how about that? So our patch panel here, my wires, untwist them, lay them into the patch panel, the 110 block, if you will. Then I'll use my punch down tool, again, 110 blade, looking at the cut side over here. Here's the chisel side. I will punch those wires into the patch panel, hopefully like you remember doing in our lab just a few weeks ago. And there's my patch panel termination. So a lot of overlap between the 110 termination and the patch panel. Absolutely. As we developed I should say made our cabling system better over time, we'll put it that way, the 110 block part of our system was pulled out and used for the patch panel because it was a very good termination with very little wire and twist, but a good electrical and mechanical termination. So that has been incorporated into the back of our patch panel. Changing gears now to our 66 block. I might run into these for phone termination. So the 66 block, for phone termination, just reminding us, here's our 66 block here, usually is on a wall here near our phone server, and our phone lines are being terminated to it. So again, reminding you, our phone switch, our phone server, big pair connector cable here into the side of our 66 block, and then I would be using jumper wires from block to block out to our phones. Okay, so we're looking at this 66 block. The wires come in and get terminated into these little pins that are in here in the 66 block. So strip the insulation, separate my pairs, get my tool ready. Now I can use the same punch down tool, but I need the 66 blade this time. This is my 66 blade right here. So I will put that in. Once I feed the wires into the 66 block, take my my punch down tool with the 66 blade in, punch down on top of the pin and terminate just like I would before. And then as I need to connect from side to side of my block, because again, I have this going on, wire coming in here, wire coming in here. As I need to connect these two halves of the block, I can use little bridge clips like so, and that'll allow me to connect side to side or disconnect. I could also pull that clip out, and I could punch a wire from here down to here if I need to connect different phones. And that's what they're showing you with the little bridge clips. Next termination we run into is our outlet jack termination. Actually, I'll pause while I'll come back in the next podcast and talk about this termination.